Myself, Dr. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about definitions and terminology related to the Module 3, that is CPU and Computer Arithmetic. The first term that I will going to discuss is what are the four categories of micro operation. First, we will discuss about what is micro operation. In a microprogrammed control, the micro operations are performed by executing a program consisting of micro instructions. So, in the controlled memory, the microprograms can be stored. A microprogram is collection of micro instructions. The micro instructions can consist of the micro operations. So what operations are to be performed on the specified operand is described by the micro operation. In computer central processing unit, micro operations are detailed low-level instructions used in some design to implement complex machine instructions. So in the instruction format, opcode and address can be specified. The opcode specifies the micro operation that can be performed on the specified address, the operand value. So here there are four categories of micro operations. One is register transfer micro operations. These operations are used to perform on the CPU registers the micro operations. Arithmetic micro operations. So these operations are used to perform the arithmetic micro operations. The processing capability can be added to the computer with the help of these arithmetic micro operations. Logical micro operations can be used to perform the bit level manipulations so that decision making capacity can be added to the computer. Shift micro operations are used to perform the serial transmission of data. Variety of these micro instructions can be described, and the basic example, the general micro operations are add, sub, come under the arithmetic micro operations. In the category of logical micro operations, XOR and OR are come under the logical micro operations. Shift micro operations means left shift, right shift, SHL, SHR. The micro operations can be under the shift micro operations. In the register transfer micro operations, move, store, load, these instructions can come under the register transfer micro operations. Define arithmetic micro operations. The basic micro operations just now we discussed. So the arithmetic operations can support all arithmetic processing. So they can provide the computational capability to the computer. Generally, the addition micro operation, subtraction micro operation, increment micro operation, decrement micro operations are various examples under the category of arithmetic micro operations. So here is the list of macros that can be used in the assembly language related to the arithmetic micro operation. To perform the increment operation, INC. To perform decrement operation, DEC. To perform addition, ADD. To perform subtraction, SUB. For multiplication, MUL. And for division, DIV. Addition can be performed along with carry with ADC. Subtraction can be performed along with borrow with sub-B. Subtract in the reverse can be performed with the sub-R. Negate operation can be used to perform an easy opcode. So these are the mnemonics that can be used related to the various arithmetic operations. The first micro instruction that can be come under the category of arithmetic is the increment. The increment micro instruction can add a one value to the register specified in the assembly language program. And decrement can be used to subtract a value 1 from the stored register or the memory word. Add performs arithmetic addition on the values stored in the specified registers or the memory word. Next, subtract performs arithmetic subtraction on the values stored in specified registers or the memory word. Multiply is used to perform arithmetic multiplication on the values stored in the specified registers or the memory word. Divide used to perform the arithmetic division on the values stored in the specified register or memory word. Add with carry performs the addition on two operand plus the value of the carry from the previous computation. Subtract with borrow. Subtract two words and a borrow which may have resulted from the previous subtract operation. Negate produces 2's complement of the value stored in the register. All these are variety of arithmetic micro instructions. How to apply these arithmetic micro instructions? INC R1, the register R1 value can be incremented by 1 with the help of INC micro operation. DEC R2 means the value of the register R2 can be decremented by 1 with the DEC micro operation. Add R1, R2. Register R1 value and R2 value can be added and the result is stored in the register R1. Sub R1, R2 means the value of register R2 is subtracted from the R1 and the result is stored in the register R1. In this way, the arithmetic micro operations can be used in the assembly language program. What is the use of logic micro operations? So, the next category of micro operations are the logic micro operations. These operations generally used to provide a logical decision making capability to the computer. The logical micro operations can be used to change the bit values. So, bit manipulation can be possible with the help of logic micro operations. So, the logic micro operation can has the capability to change bit values, delete a group of bits and insert a new bit values into the register. So, logic micro operations specify binary operations for string of bits stored in the register. These operations consider each bit of the register separately and treat them as the binary variables. So, single bit can be extracted or fetched from the register and can be applied the logical micro operations. For example, the exclusive or micro operation with the content of the two registers on the each respective bits of two registers, the exclusive or operation can be performed. There are 16 different logical operations that can be performed with two binary variables. And here is the list of various logical micro operations. They are to clear, that is storing a zero value in the specified register, CLR mnemonic can be used. To complement, COM. To perform AND logical operation, AND. To perform OR logical operation, OR. To perform exclusive OR operation, XOR. To clear the carry bit can be equated to 0 with the help of CLRC. To set the carry bit can possess a value 1 with the help of set C. Complement of the carry can be performed with the mnemonic COMC. Not only that, the enable interrupt can be enabled with the EI and can be disabled with the help of DI. So, what are these logical instructions? The first instruction is the clear. The clear instruction causes the specified operand to be replaced by 0. So, the value 0 is stored in the specified register. Complement produces the ones complement by inverting all the bits of the operand. That means it can replace 0 as 1, 1 as 0, and performs Boolean and operation on the individual bits of the operand. OR and exclusive OR can perform Boolean OR and exclusive OR operations on individual bits of the operand. So the logical instruction can be capable of extracting each bit and can apply the logical micro instruction on the individual bits of the operand. Clear carry, individual carry bit is cleared or set to 1, set to 0. Set carry, the individual carry bit is set to 1. Complement carry, individual carry bit is complemented. Interrupt enable, interrupt is enabled with the help of flip-flop. So EI is the mnemonic used for this purpose. Interrupt is disabled with the help of the flip-flop. DI is the mnemonic used to disable the interrupt. So all these are various varieties of logical micro operations. Now how to apply these logical micro operations. So clear. So on the register C, so here it has to be stored a 0 value to this. Next set C. So C can be used equated to 1. So the carry bit clear C and set C can be used to manipulate the carry bit, and complement of the carry bit can be taken with the CPLC. And to perform AND operation or operation on the individual bits of the operand, ANL, ORL on the register can be specified. So in this way, the logical micro operations can be applied. What is clear operation? So clear operation is used generally to initialize the registers. A 0 value can be stored in the specified register or in the memory word. Compares the bits in A and B and produces an all 0 result if the two numbers are equal. This is the logical clear operation. So for the example, we can consider two registers A and B. A is possesses the value 1010. B is contains the value 1010. So what is logical clear operation means? It can compare the each and every respective bits of register A and B and produces the result 0 if two numbers are equal. So the 0th bit of A can be taken and 0th bit of B can be taken and a comparison can be made. So 0th bit of A is 0, 0th bit of B is 0. So the value, the result register value can be 0. This is before performing the clear operation of the value of the register A. This is after performing the clear operation on the register A. So here both are equal. 0 can be set in the resultant A register. Next bit can be considered. So in the A register the value can be 1 and in the B register also the value can be 1. So both are equal, it can be cleared 0. And here in the third bit also 0 0, fourth bit also 1 1. So all can be the zeros to the A. It can be equal to the exclusive OR operation on the A and B. What is selective clear operation? So here clears the the bits of A only where they are corresponding ones in the B. So here consider two registers A and B, and here it can compare the respective bits of the registers A and B. When there is a one bit in the B, the respective bit of A can be clear to 0. So before performing the selective clear operation, A value is 1010 and the B value is 1100. Here the corresponding bits of the registers, two registers can be compared. So 0th bit of A and 0th bit of B can be compared. So here both can be 0, 0 equal to 0. So the resultant A value can be 0. And consider the second bit 1, 0. So it is also 1 as it is the bit can be transmitted to A. If at all there is a 1 bit in the B, then only the value has to be, the respective value can be cleared in the A. So in the third bit, if you compared here, it is the 1 value. So the corresponding bit can be cleared, but here it is 0. So 0 can be used here. But in case of next bit, here a 1 value in the B, the corresponding bit in the A can be 1. So it can be cleared. So 0 can be copied here. So after performing selective clear, the A register value can be 0010. So this is the selective clear operation. What is the mask operation? Similar to the selective clear operation, except that the bits of A are cleared only where there are corresponding zeros in the B. In the selective clear, if it all B possesses a value of 1, then the respective bit of A can be cleared. But in case of mask operation, if the B bit is possesses a value 0, the corresponding bit of A can be cleared to 0. So consider an example. A register can contain the value 1010 and B register can contain the value 1100. Now we have to take the B bit value. It is a 0. So the corresponding bit in the A can be cleared. It is also the 0. So same 0 can be written here. Next, the second bit can be considered. Here it is 0, but the corresponding bit in the A is 1. So it can be cleared to 0. So here 1, 1. So same values can be copied to the A register. So this is the mask operation. So when there is a 0 bit in the B register, the corresponding bit in the A register is cleared to 0, can be referred as the mask operation. Define shift micro operations. So previous slides we discussed about the arithmetic micro operation as well as logical micro operation. Now the next category is shift micro operations. So what are shift micro operations means? These operations are used for serial data transfer. The contents of a register can be shifted either to the left or to the right. There are 3 categories of shift operations can be available. One is logical shift, circular shift and arithmetic shift. In each shift again either left direction or right direction shift can be takes place. So there are totally 6 micro operations are available regarding the shift micro operations. So what is the shift left, logical shift left operation? So in the shift left operation, the serial input transfers a bit to the rightmost position. So here each bit can be traversed in the rightmost direction, the bit can be traversed and there is an empty position can be created at the LSB. We will discuss that with an example. Shift right operation means the serial input transfers a bit to the leftmost position. So in each shift, each category, the bits can be traversed either in left direction or in the right direction depending upon the type of the shift, either the left shift or the right shift. Now consider the example of the left shift micro operation. So here each bit has to be moved to the next successive operation towards the right like this. So here an empty position is created at the LSB. So that position can be filled with a 0 and the MSB position can be discarded in case of left shift micro operation. What is the logical right shift operation? So here the bits can be moved towards the leftwards. MSB can be, the empty position can be created at the MSB and can be filled with the 0, and the LSB bit position can be discarded. So there is a loss of information or data in case of logical shift micro operation. What is arithmetic left shift micro operation? A left arithmetic shift of one position moves to each bit to the left by 1. The vacant least bit position can be filled with 0 and the most significant bit is discarded. That means it is identical to the logical left shift operation. So here the bits can be traversed to the rightwards, and here the empty position that is available at the LSB can be filled with a 0 and MSB bit can be discarded. But there is a variation in case of arithmetic right shift micro operation. A right arithmetic shift of one position moves each bit to the right by 1. The least significant bit is discarded and the vacant MSB is filled with the value of the previous bit of the MSB. So here the MSB bit can be copied to the two positions, the previous position and the their position, and the remaining bit can be traversed to the right in the arithmetic right shift operation. So this is a variant from the logical right shift and the arithmetic right shift. But the left shift operations can be identical in case of logical shift as well as arithmetic left shift. What are circular shift operations? The circular shift circulates the bit in the sequence of the register around the both ends without any loss of the information. So in the previous cases, there is a loss of information. To avoid that, the third type of shift operation can be used, that is circular shift operation. So here, what is the discarded bit at the MSB in case of left shift operation can be transmitted, can be used to fill the vacant position at the LSB. So the MSB bit is circulated and can be used to fill the LSB position. That's why this operation is called circular shift operation. In case of right circular shift also, what is the vacant position that can be used, the discarded bit can be used to fill the vacant position at the MSB. So this can be the right circular shift operation. So here three varieties of shifts are there: logical shift, arithmetic shift, circular shift, or we can call it as rotate. So to perform in this each category, again two sub varieties are there: left shift and right shift. So totally 6 micro operations can be needed to perform these shift operations. So the mnemonic that can be used to perform shift left operation is SHL, and to perform a logical shift right operation is SHR. To perform circular left shift operation is CIL. To perform circular right shift is CIR. To perform arithmetic shift left operation is AHL. To perform arithmetic shift right operation is AHR. So by using these mnemonics, the shift operations can be performed. How these shift instructions can be used in the assembly language? SHR R1, 1. So one bit can be right shifted of the register value R1. SHL means left shift 2 bits of register R2. SHRA means arithmetic right shift. 1 bit of operation can be performed on the register R1. SHLA means arithmetic left shift. 1 bit operation can be performed on the register R2. ROR is register right shift on the register R1. Rotate or circular left shift on the register R2. So along with carry, the circular shift can be performed with write operation RORC on the register R1, ROLC on the register R2 that represent the circular left shift along with the carry on the register R2. In this way, the shift operations can be used in the assembly language program. Define throughput. So it is the total number of processes completed per unit time, or rather it can be referred as total amount of work done in a system unit of the time. So the number of instructions that can be executed per unit of time. For example, say 1 second, that can be treated as the throughput. So in a single program, single user and single tasking systems, the throughput can be generally low. In case of multitasking system, more than one user program can has to be simultaneously executed. So the number of instructions executed per unit time can be more. So the throughput can be more. What is overflow? So when the absolute value of the number is too high for the computer to represent it, then the overflow can be occurred. When two numbers of n digits each are added and the sum occupies n plus 1 digits, referred as an overflow occurred. In the CPU registers, each register is of fixed size. If at all an overflow bit n plus 1 digits are occurred to store the values in the registers, then it could be difficult. So an overflow is a problem in digital computer because the width of register is finite and fixed. So to indicate the overflow in the status register, the V bit can be used. So if E bit is 1, then an overflow occurs. Depending upon that, the corresponding operations or overflow condition can be treated. A result that contains n plus 1 bits cannot be accommodated in a register with a standard length of n bits. So for this reason, many computers detect the occurrence of the overflow. So how can be it can be detected means with the help of status register overflow bit V bit, and when it encountered, a corresponding flip-flop is set which can be checked by the user. In this way, the overflow can be handled by the user. Define underflow. The absolute value of the number is too close to 0 for the computer to represent it. So underflow can be easily handled by the combinational circuits. What is turnaround time? It is the amount of time taken to execute a particular process. So the time required to complete one execution of one instruction, that is generally referred as turnaround time. The interval from time of submission of the process to the time of completion of the process can be generally considered for the turnaround time. Define waiting time. So all the jobs that are available, the tasks that are available in the queue could not be taken by the CPU for execution at a one stretch. So fair scheduling algorithms can be used for this purpose, which task can be selected from the queue for the CPU execution. The other task can be in the waiting state. The sum of the period spent waiting in the ready queue, amount of time a process has been waiting in the ready queue to acquire get control on the CPU. The resources that are needed for the execution of the task can be ready, so that the task is waiting in the ready queue to get selected by the CPU for the execution with the help of scheduling algorithm. So the time required for the process to select from ready queue to move ready queue to the CPU execution is generally referred as the waiting time. What is load average? It is the average number of processes reside in the ready queue waiting for their turn to get into the CPU. So that is referred as load average. The average number of processes that are waiting for the CPU execution in the ready queue is generally referred as load average. Define response time. Amount of time it takes from when a request was submitted until the first response is produced. This response time is very important for the application execution. When the user submitted a request to the computer, the time lapse to get its first response from the computer is generally defined as the response time. So this is the time till the first response and not the completion of the process of execution. So this response time can be very low so that the user cannot be frustrated to operate with the computer. What is signed division? So user negate the quotient if the signs of the divisor and dividend is disagree. The remainder and the dividend must have the same signs. So before processing to the division algorithm, the signs can be compared with the help of exclusive OR gate to avoid this situation. Define combinational circuit. Combinational circuits are made of logic gates. So here the basic electronic gates can be used for the purpose of the combination development design of the combinational circuit. It does not contain any memory elements. They cannot store any information. The value present output is determined by the present input. Example of combinational circuits are half adder, full adder, subtractors. The example of one combination circuit is 4-bit binary adder. So this adder circuit is fully constructed with the full adders. No memory element is used here. Okay. What is multiplexer? A multiplexer is a combinational circuit where binary information from one of many input lines is selected and directed it to a single output line. So many to one is generally referred as multiplexer. So here this is a combinational circuit. In this multiplexers, 4x1 multiplexer can be used. That means each multiplexer can receive 4 inputs. Only one output is taken from this multiplexer. So in this way, many outputs to many inputs to one output selection can be done with the help of the multiplexer. So in this video, what are the definitions and terminology related to the CPU and binary arithmetic can be considered and discussed. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.